Now, I would like to invite Shikha Urmil to introduce our extreme renowned resource person. So, Shikha,
Yes, sir. Am I audible?
yes, yes, Shikha.
Yes.
A very good evening to everyone present, and a warm welcome to the AICTE Atal Online FDP titled Green Energy Resolution, Research, Innovation, Policies, and Sustainable Solution. This is Shikha Urmil, and I'm here to introduce our renowned resource person, Professor Dr. Manvinder Singh Pava. Dr. Pava is an esteemed alumnus of prestigious Indian Institute of Management, Ahmedabad, a distinguished academician with a prolific career spanning 25 years. The core areas of his expertise include business analytics, entrepreneurship, business finance, and corporate laws. Dr. Pava is a professionally qualified company secretary and a gold medalist in LLM MBA. Also top ranking in LLB, PGDHR, and PGDIB. As company secretary, his significant contributions include the incorporation and dissolution of over 200 companies, along with facilitating corporate fundraising through banks, financial institutions, NBFCs, and project financing mechanisms. Dr. Pava has conducted and delivered over 150 specialized courses and management development programs for IIFCL, IPL, Indian Oil, ONGC, PFCI, etc. His expertise also encompasses delivering FDPs for both government and private institutions, including AICTE, ICSSR, UGC sponsored FDPs, and UGC HRDC Freshers Courses Orientations Program on use of artificial intelligence, business analytics, research methodology, pedagogy, personal effectiveness, work ethics, soft skills, SPSS, legal compliances, entrepreneurships, and modeling. Dr. Pava has actively participated in numerous national and international conferences and has chaired multiple sessions. His publications include 70 research papers in reputed national and international journals, including Scopus Index journals, conferences, proceedings, and books. Under his guidance, each PhD scholars have successfully completed their doctoral research and several more currently pursuing. Dr. Pava was awarded 3 patents in recent past in recognition of his research contributions. Presently, Dr. Pava holds the esteemed position of professor in Department of Commerce and member of Academic Council, Dr. Harisingaur University, Sagar, Madhya Pradesh. So please welcome Dr. Manvinder Singh Pava. So this is all from my side.
Sir, we welcomes you, sir. Powers, Dr. Professor Manvir Singh Pahwa, sir.
Yeah, thank you. Am I audible there?
Yes, sir.
Okay. So, with permission of Honorable Vice Chancellor, sir, should I start my session? This is the first session we are going to start. Sir, with your permission, sir.
Yes, go ahead, please.
Thank you, sir. I wish Happy New Year to everyone. This is English New Year, which has started, or you can say calendar New Year 2026. I welcome all of you to this new year, and I wish all the best to everyone for the upcoming year. And may you all have the grace of God with respect to prosperity, your success, and the most important thing, that is satisfaction. So today we are going to talk about energy, the renewable energy, and this is the basic session, the first most session with which we are going to start our things. So before I just take it up, let us just see how many participants do we have, Lokesh ji, by the time?
Yes, sir.
How many participants have logged in? 85,
Sir,
I suppose.
sir. At the time we have 93 participant logged in, sir.
Great, great, great. That's a good number. And Means because it's a FDP and we all are in front of the screens just now. Honorable Vice Chancellor Professor Yashwant Thakur sir was telling about the present position of Delhi. Delhi is amongst, unfortunately, amongst the most polluted cities of the world, and the reason is the fumes. It has sir has explained it as a gas chamber, and for sure, if you reside in Delhi, your life is going to be depleted by it, at least by 10 years, as sir has just now said, and very correctly said and explained by. Now, why this has happened? This has happened because of the exploitation of the resources which we have done, and we are still doing it. And the things have now become uncontrollable. So before we start, because what the thing is, we need energy. So let us just talk about. I want this session to be a more interactive one. So let me ask some of you what energy is and why we need it. What is energy, by the way? Anyone?
Sir,
Yes.
it is capacity to do work.
Okay. Capacity
To do work, any
to
work.
do work. What type of work we are going to do with this, and in what capacity we are going to do that?
Every work that need some energy.
Every work needs energy. Okay. Okay. So what are the efforts which we have to put in order to do the work as such that whatsoever means what type of work we do. Every work, whatever we do means even speaking needs, even sleeping also needs some energy. So that is also one of the things. And how? And my next question is from where this energy is coming from? From where this energy is coming from? Anyone?
From two sources, renewable and non-renewable.
These are the sources, but whatever we are feeling means we might be feeling energetic. Sometimes we may feel a little low also, right? So
Yes, sir.
from where we are actually seeing this energies are coming from?
From nature, sir.
The sun is primary sources, sir.
Okay, okay. What are the primary sources? Can you please share that? It's already on. It was already on the
Primary
screen. It's
sources.
already on the screen. The primary sources. Yeah.
So primary sources are solar energy, wind
Mhm.
energy, hydro
Okay.
energy,
Okay. What else?
so thermal.
Hmm. These days, energy is being generated even by a flowing water. Even under the sea, we are generating the energy. So with the help of this energy, we are doing our work. Let me share my slides with you. Just a moment. Can you see the screen? Okay. I hope the screen is
Yes, sir.
visible to everyone. Okay. So the most important thing is uh, is the understanding the energy that makes the foundation. As we have just now discussed, what energy is. Energy is the ability to do the work. Somebody has told. And what type and from where this energy is coming from is that means we from why everything is moving in the world and since when it is moving. Since when we have started moving. You might have heard about the supernova explosion. I would say it's an act of God. When the God has decided to be multiple, then these things have started. Since then, we are moving. and our universe is also moving. And sometimes whenever we just the speed of the earth with which the earth is moving in the universe is very, very high. We can't feel it. Why? Because uh, there is no relative things with which we can see whether we are moving or not. So particularly if we see, the things have started, the energy which we are getting, it's nothing but the state of the God which has created the world at the time. The time has also started since then only, and we all are moving. We all are having the direction to move, and everything whatsoever is happening, we say it's a will of God. We always say it like that. So again, everything whatsoever we do is something which is gaudy, or you can say something which is happening by the grace of God, you can say. Now if we just take a simple example of our human body, we have the energy from heat, we have energy from light, from motion we do, and the ability to cause change, or you can say the capacity to do work, defines this in a better way. Now, energy, as I have just now told, it's a universal phenomenon that whatsoever is in the universe is existing is because of the energy in it. So, if we see it from the discipline point of view, if we talk about physics, you can say work, uh, force, motion. So energy in physics is, you can say, it's a central concept that actually connects the force, work, and the motion, and helps to explain how and why the physical processes occur. Okay. So energy is usually defined as a capacity of a body or a system to do work, that is to produce change in a moving object, deform it, or changing its temperature also. So whatsoever we are doing, if we are able to make any change, may it be temperature, may it be speed, we are applying the energy, and energy itself, if we say, is a scalar physical quantity and is conserved in a isolated systems. It can neither be created nor destroyed. It can only be transformed from one form to another. This definition we have studied when we were in class 7th or 8th. For example, from potential energy to kinetic energy, there is a change. Or from, you can say, from chemical energy to mechanical energy, as we are changing, as we can see that the things are going from the chemical to mechanical. How they are going from our vehicles are very good example of this. So this conservation principle makes energy a powerful tool for analyzing motion in the mechanics as well as phenomena in the thermodynamics, you can say, right? And in mechanics, if we see, so the energy is most directly linked to the motion, to the kinetic or the potential energy. So kinetic energy is an energy a body possesses because of the motion itself. For a particle of mass moving with the velocity v, the kinetic energy can be defined. It can be given by a formula, right? And it can increase or it can decrease. So what potential energy is, if we say it from the physics point of view, so potential energy, by the in contrast to the kinetic energy, is associated with the position or configuration. A body raised in a gravitational field has a gravitational potential, while compressed springs, they stores a lot of you can say elastic potential energy. When it is released, or when the objects move under the influence of the forces, there is a continuous exchange between the kinetic and the potential energy. For example, you can just take example of a falling body. For falling anything means anything which is falling, it loses the gravitational potential energy and gains the kinetic energy. and yet the total mechanical energy, that is a kinetic plus potential, actually remains constant in the balance of the non-conservative forces like friction. So the bridge between the force motion and the energy is the physical quantity that is called work. That's what we define to the work. That it is actually something which you have applied, some force which you have applied, and with that force particularly, when you have applied that particular force, there is some motion which has happened, right? So from the context or from the point of view of physics, you can say in physics the work is done by force, where it causes a displacement of a point of application. The force is in the direction of that, the force, we can say, is in the direction in which it has done, right? So if the constant, you can say, force is acted upon a body, it produces certain, you can say, displacement. Then that particular displacement can also be representative with certain formula, and we can say that some work has been done. So positive work actually corresponds to the force that applies the motion, you can say. Like you can say, you can push a cart, or whereas some negative work corresponds to a force that opposes the motion, such as, you can say, slowing a block which is sliding, or you can say you are stopping something which is moving in a certain direction. So these are the examples. So zero work is done if there is no displacement, if the force is perpendicular to the motion, as in the case of centripetal force in the uniform circular motion, then we can say that there is no work which is being done. Means even if you apply some force to certain thing and it has not been displaced, then we can say we have not done anything. It means that there is no work done, there is no energy being consumed. So the link between the work and the kinetic energy is formalized in the work energy theorem, you can say, right? So particularly when we are talking about energy in biology, you can say, so energy in biology is about the living things, and they get energy to stay alive, that is from metabolism. Or you can say metabolism means all that chemical reaction that happens inside a cell or a body, right? And this provides the energy. The very good example is photosynthesis, which is a process which helps the plants to get the energy or plants to get the food from. Okay, so there are two main parts of metabolism, you can say. The one is called catabolism, which is big food molecules, like you can say sugars and the fats that are broken into the smaller pieces. When this happens, the energy is in a special molecule which is called ATP. So ATP is just like, you can say, a small rechargeable battery for the cell, particularly. So like catabolism, another thing is anabolism. So the cell uses the energy stored in that particular ATP to build important substances such as proteins or DNAs or the other part of the cells, and this helps in the growth and repairing and making the new cells. So there is always an energy whenever, let us just consider it from the point of view of a mythology, or you can say from the point of view of the sciences, which is beyond the, or you can say the things which are beyond the sciences. When a person takes birth, it itself is having some energy inside it, which actually makes it move. The small child cries like anything. So these are the things which are actually there. So what actually is happening? There is some process which is going on, which is providing the force, or you can say providing the energy to that particular things to work on. And these reactions actually occur in steps, or you can say in pathways. So each step is held by the protein, which we call it as an enzymes. So enzymes make the reaction faster and control when and how they happen. So in this way, the metabolism actually provides energy in movement, or you can say the transportation of the substance out of the cells and building the cell structure. It also helps in keeping the organisms alive and healthy. Now, next is something which is related to, I have discussed two things regarding from the scientific point of view. Another two things are from the point of view of, you can say, social sciences, economics. Or you can say energy is nothing but an input to the production. So can anyone tell me about how the energy is related to economics? I have just given a hint over here. How can you see energy from the point of view of economics? Anyone? Let me make this thing more easier. We have certain, you can say, production function, if you might have heard of. So there are certain sources which provides, or there are certain things which helps in production, like land, labor, capital. So how does the energy is related to economics? Anyone?
Sir, good evening, sir. I'm Dr. Krishna from School of Management, Hindustan University.
Yeah, welcome, sir. Yeah, please
Good
tell
evening,
me.
sir. Good evening, sir.
Yeah, very
And
good evening.
warm welcome, sir. So, as just I'm trying to attempt this energy as a sort of production, as we just not all factors of production, land, labor, capital. So,
Yeah.
we need water, we connect to hydroelectricity. We need
Uh-huh.
light, we connect to solar electricity,
Mhm.
solar energy. So
Yeah.
each production, like we need water, we need light, we need electricity, hydroelectricity, thermal electricity, solar electricity. These are required for factors of production. So when we start an entrepreneurship or enterprise, I think different source of energy is required for the production purpose of each which is resourceful and taking the industry forward. I'm trying to attempt, sir. I don't know how far this is correct.
Yeah, you are very correct. You are very correct. So what the thing is, there are certain inputs, just like you can say land, labor, capital, but they have some unique characteristics that make it indispensable and only partially substitutable. These things are not substitutable fully. So in modern economics, we can treat energy only as an intermediate good, which is, you can say, which is considered inadequate. But
Adequate.
no production activity can occur without some direct or indirect use of energy,
Yes, sir.
right? So,
Yes.
meaning of energy as an input in the production economics, energy refers to all form of usable power employed to transform the inputs to the outputs.
Output.
Because we are actually talking about transformation.
Yes, sir.
Energy basically is used for transformation. So when we are transforming something, may it be, and in economics and in industry, what we are doing, we are actually transforming some inputs to the outputs in order to make it usable for the public, or so that we can sell it. So the
Resourceful.
inputs, yes, of course, absolutely.
Yes.
So as electricity is there, coal, gas, biomass, and these all are renewable sources which we have just now discussed. Shikha was telling us about all these things just now,
Yes,
that
sir.
these all are the sources of the energy, or you can say these are the things through which we actually get the energy, or you can say the sources like solar and the wind. So these are the inputs. So every stage of production, sorry, the extraction of raw materials, transport, processing, or you can say the manufacturing, storage, distribution, this requires energy to run the machines
Yes, sir.
and operate the infrastructure, or you can say support the human labor. So traditionally, if we see the production theory, the classical and the neoclassical theory, if we talk about, usually they treat land, labor, and capital as the primary factors,
Yes, sir.
while materials and energy were classified as the secondary factors or the intermediate inputs derived from them, right?
Yes, sir.
So the combination of these actually make the things work in economics,
Yes,
right?
sir.
Thank you
Yes,
so
sir.
much, Krishna ji.
Thank you, sir.
So
Defense may be one industry which may think on this
absolutely,
direction, sir.
absolutely,
Defense.
absolutely, yeah,
Yes, sir. Thank you, sir. Yes, sir.
yeah. So if we talk further, the standard production function which was given by Cobb Douglas, if you have gone through that, and from often it often includes only capital and labor, implicitly assuming that the role of energy can be captured through these two variables or through the technology term. So, modern perspective, if we take about, then energy is a core factor which we are taking as such. Or empirical and theoretical work since you can say late 1970s, they argue that the energy is a distinct value creating factor of production because it animates both labor and the capital. Okay, so machines, or you can say capital, or the workers, you can say the labor, can produce output only when they are supplied with adequate energy. So output depends on the triad of, it's a triad of capital, labor, and energy rather than only capital and labor, right? So role in the economic growth and development, if we see from the point of view of energy, it is we can say that energy is closely linked with the economic growth, as most of the production and the consumption activities such as industrialization, transport, urban services, you can say digital infrastructure which we are seeing, they require continuous energy flows. And many studies therefore they describe electricity and the commercial fuel as the fifth factor of production, rather it has been now been included as such. Okay, or you can say it's a key input for a sustained development, right? Especially in developing countries like India, they seek industrial expansion. Okay, and where industrial expansion is required, these things are very, very important. A continuous. Just take example of Gujarat. Gujarat has almost zero default in electricity supply. Means the electricity supply is so continuous over there that the power doesn't goes off. Specifically in Ahmedabad, or you can say Rajkot, Surat, these areas which are more industrially developed. So this is something which is required. Or you can say, if we talk about the substitution or complementary and efficiency, there is an important debate on whether the energy can be substituted by capital. Sorry. For example, using more efficient machinery can we substitute the capital with that of energy, or you can say whether the two are mainly complementary inputs. So policy emphasize on energy efficiency actually, cleaner technologies and structural changes. They aim to reduce the energy intensity of output, getting more GDP per unit of the energy without constraining the growth. Okay, so this is another thing. And if we one more thing is there, if we talk about the environmental and the policy dimension, because most conventional energy use generates pollution and you can say the greenhouse gas emission. Energy inputs decisions have direct implication on the environmental quality and the sustainability, which we have just now been talking about. So energy economics, if we say therefore, is it analyzes the prices, taxes, regulation, and the incentives that can shift the production towards the less energy intensive techniques, and greater reliance on, you can say, renewable while maintaining the economic efficiency. So overall, viewing the energy explicitly as an input for production, it actually clarifies its central role in determining the output growth, or you can say the technological choice and the environmental impact. And it helps in designing coherent energy and the development policy of any of the country. If we talk about sociology, sociology also comprise of the energy which actually changes the quality of life. Okay, so sociology uses the idea of energy and quality of life to explain how the patterns of the energy production and the consumption shape the social structures, inequalities, lifestyles, and human well-being. So it treats the energy not just as a technical or economical input or economic input, but as a social variable that underpins the modern life, and actually it enhances or changes the development. So if we talk about the meaning of energy in sociology, or you can say in sociological terms, energy can be referred to, to the socially organized system that generates, distributes, and uses electricity in fuels in the everyday life. So these systems actually influence where the people live, how they work, how they are traveling, and how they are communicating. They participate in the community life. And from this angle, if we see, the energy is embedded in the institutions such as markets, states, households, and sorry, global regimes, rather than being the neutral resource. The shift from the traditional biomass, fossil fuels which we were using, and now to the renewables is therefore also a shift in the power relations, structural practices, and the social identities. And if we talk about the concept of the quality of life, if we see, so the quality of life in sociology is a multidimensional concept, we can say, which is beyond the income, and it mainly includes health, education, housing, social participation, or you can say most importantly the environmental conditions which we were discussing just now about the about Delhi, that how the things are going on over there. So do we call ourselves as socially developed when we have to live in such a polluted environment like Delhi? It's a big question. So Delhi people, they think they are well developed. So is this a development? Is this a social development, or is this a social transformation? So human development index, if we talk about, and the satisfaction scores, these are often used to optimize the broader areas, you can say, right? So here, if we talk about, you can say, why do we need energy particularly? Then we can say that energy is needed, or energy needs increase in the scale and the complexity from the individual to the national level. But all are interlinked through a common goal of supporting the human development and the economic activity. See, until and unless we do, or we think about ourselves means humanity, or you can say the world. We cannot say that we are doing any development, or anything which we do is, if it is not human centric, it is useless. So there are certain levels, you can say energy needs are there at different levels. At individual level it is there, household, industry, nation, and there is a relationship between the energy consumption and the human development index, which we were just about to talk about, right? So it actually, if we see it from the point of view of individual level, so energy is primarily biological and is measured in dietary energy, the intake which we need for our metabolism or physical activity, growth, and the special conditions, like you can say, the pregnancy of a woman. So they need energy. So this is something at the individual level we need. So adequate individual energy intake is the prerequisite of a productive work and the participation in the society. So it indirectly shapes the wider energy demands. So first of all, we have to see ourselves, and then we have to go to another level, that is, you can say, the household level. So at household level, the need expand to, you can say, cooking, lighting, space, you can say space heating, or you can say cooling like ACs, or you can say water heating, or powering any appliances. So in many developing regions, household use a mix of traditional fuels, that is the biomass, like we are using the gas to prepare our food, daily food, and the modern fuels like you can say the solar power. And the this shift is at the upper energy ladder, which is closely associated with the incomes and the urbanization. So, reliable, clean, and household energy is central to the education, health, and the quality of of life outcomes. So, whenever we are talking about the household energy, then we are talking about something which at masses the individuals are needing. Next is your industry. So in industry, energy is critical input for production processes, we know very well, especially in energy incentive sectors such as you can say steel, cement, chemicals. So these are something which need energy in a or you can say they need power in more quantity, you can say. So industries often they use electricity or you can say coal or the natural gas or whatever petroleum products and and efficiency improvements here significantly influence the national energy intensity and also the emissions at the national level. So at national level, if we talk about, because this is something individual, when they combine together, they form household. The things which are household are required. It is coming from the industry, and when we talk about nation, the combinations of all these things form a nation. So at national level, the total energy need cover the household, industry, transport services, agriculture, and whatnot, and everything which is closely you can say tied to the development indicators and the poverty reduction. So national energy policy must therefore ensure the sufficient, affordable, and sustainable supply while expanding access to the electricity for the population who are lacking it. Now, what is the relationship between the energy consumption and the Human Development Index? You might have heard about HDI, Human Development Index. We all are teachers, right? Anyone? What actually it is, Human Development Index? It's a relationship between the energy consumption. There is a relationship between the energy consumption and Human Development Index. Now, actually, what the thing is, when we are talking about human development, there are various things which comprise of human development. Not all things are equally important, but at the global level, whatsoever has been thought of importance, particularly in development of certain index, multiplied by their importance level. So there is a figure which comes up, which is called Human Development Index. Now it differs from country to country. So now, if we talk about Human Development Index and we have higher Human Development Index, definitely the particular country will be having more individual satisfaction level, more happiness. Today, these things, happiness index is also being calculated by various things which makes a person happy. So there are certain things, and these are attempt to quantify the development. Now there is a relationship between the energy consumption and the Human Development Index is normally or generally considered to be positive, with a clear threshold and the diminishing returns. So HDI, or you can say Human Development Index, actually captures three basic dimensions of human well-being. Number one is long and healthy life. Second is access to the knowledge. And third is a decent standard of living. Now, if you go behind this, there will be some more factors which are affecting the long and the healthy life, access to the knowledge. So there can be various things. So combinations of all things has in a in a proportionate way actually holds this what you call is a Human Development Index, right? So these all require a reliable energy services for their household production and the public infrastructure, which actually is provided by the nation to the people in order to have a better HDIs. So at low levels of development, even small increase in the per capita energy can cause a sharp improvement in HDI by enabling the clean water supply, you can say lightning, basic health services and education facilities. Now, if we go empirically, the empirical analysis shows a strong positive correlation between the per capita energy or the electrical use and HDI, particularly for low and the middle income countries. And some studies even have documented bidirectional causality, where the human development index further stimulates the energy demand. So, whatever the things are, however, this relationship actually flattens beyond a certain level of energy consumption, and researchers have also suggest uh, that the HDI values which are around zero point 0.9 are typically reached at roughly 4,000 kilowatts of electricity per person per year, after which further energy use contributes little to the you can say additional human development, which indicates the diminishing returns beyond these thresholds also. Okay. So further, if we talk about the excessive use of fossil fuel based consumption, which mainly uh, raises the GDP and emission rates rather than SDI, highlighting the policy challenge of expanding access to the modern, preferably the renewable energy in the poorer countries, while improving the efficiency and environmental sustainability in the richer ones. So, one message is there which actually tells that the energy is not just a technical concept, it is a social, economic, and civilizational driver, right? So, energy is not just you can say the things which can be defined only through the science and technology. Actually, it is driving the social, economic, and the civilization driver. Civilization progresses from the we have actually progressed from, if you remember about the steam engine, and now we are in a digital era where we are having our smart trains also, that that always relies has relied on the energy transition. So therefore, the energy is not merely about fuels or power generation. It actually embodies the interconnected foundation of human advancement, sustainability, and global socio-economic transformation. So let us talk something about the ancient Indian knowledge and the origin of the energy, if we see. Because see, if I would have talked about only these four sources, I think everyone knows about it. Let us just connect it with something which is related to our own Indian philosophy. So, ancient Indian philosophy actually conceptualizes energy as a primal dynamic force underlying the cosmos, which I was just talking about, right? So, this particular thing is distinct from the modern physics, and they still have the paralleling ideas of universal vitality. So, this view has emerged from the Vedic, or you can say from Upanishads or Samakhyas and the Tantric traditions, you can say, which actually portrays the energy not as a inert matter but as a conscious transformative power. This is very very important. That's why I just started with the thing that from where the energy is coming. Then when the God has thought itself to be multiple, कहते हैं ना अपन की हर एक में भगवान है. So it has happened to be like that. And central to this is the interplay of the static consciousness and active force which is shaping a vibrant universe, you can say, right? So, cosmic origin of the energy. If we talk about the energy, originates from the unmanifest. You can say Brahman manifesting through cosmic processes like the primordial sound of Om, or you can say Hiranyagarbha, the golden egg bursting into the creation, right? So Vedas, they have described the cosmic energies entering via the Shabda, this Brahma, the Shabda Brahma, that is Om, which actually transforms into mass and elements from the space, that is Akash, via Pran, the vital force which is projecting the universe. So what prana is? Prana is a cosmic energy which governs all the existence, with sun as its reservoir, because sun is the most powerful thing, and sun is the, you can say, is the most important source for us. But even before sun, there were energies which has actually created sun as such. And sun, because it is a reservoir, it links the microcosmic breath to the macrocosmic cycles. Now another concept is the concept of the shakti, that is, you can say, which embodies the feminine force. Okay, shakti, or you can say devi, or you can say the shakti which is coming from the devis, or Devis are formed by the Shakti, or Shakti is formed with the Devi itself. The dynamic power of Brahman or the Shiva is inseparable yet distinct as an agent of creation, preservation, and dissolution. That is Brahma, Vishnu, and Mahesha. So in Tantra and in the Shakya philosophy, Shakti awakens from the unity with the Shiva, manifesting Ichha, that is the will, and Janya, that is the knowledge, and Kritya, that is the activity, symbolized with the inverted triangle of the yantra. If you might have seen the yantra, okay. So this yantra actually comprise of the will, knowledge, and the activities. That is the Ichha, uh, Gyan, and you can say the Kriya. Okay, so this is something which is there, and equivalent to this Prakriti in Samakhya, the Shakti energizes the inert, turning the potential into the phenomena, as we have seen in Ardhanarishwara. That is the half Shiva, half Shakti form, you can say. So, means the universe is also a dynamic one, or you can say it is not a static. So, unlike static models, Asian ancient Indian cosmology views the universe as the eternally oscillating creation. That is the Srishti, preservation, and dissolution. That is called Pralaya, driven by Prakriti's gunas, which are Sattvic gun, Rajas gun, and Tamas gun. So Samakhya poised the Prakriti in constant flux, evolving 24 tattvas from the equilibrium, which was disturbed by the Purusha's gaze, mirroring the modern Big Bang cycles. We just say it like that. So Vedanta describes the Brahman altering between the static, that is Nirguna, and the Sagunas state, that is the dynamic. So Nirguna state is a static state, and Sarguna state is the dynamic state, with prana animating the endless rebirths. So these are the things which have which so this Shakti, or you can say the energy, is having our own mythological sources, or you can say the philosophical sources which we are having. So what are the key philosophical ideas? The core ideas, which include the dualism, that is the Purusha, pure consciousness and passive witness, and Prakriti, that is Shakti, that is matter, energy, creative agency, you can say. So interdependence for the on both actually is manifested. So Pran actually unifies the vital force, the five pranas in the body mirroring the cosmic ones, while Agni actually represent the transformative energy, conserved like modern laws. Tantra emphasize the Shakti's role in liberation, via Kundalini awakening affirms the world as a divine play, that is a Leela, not just a illusion. So these concepts actually integrate the spirit matter, influencing yoga and cosmology profoundly. So this is something which is related to, and Panch Mahabhuta we all are doing. The Panch Mahabhuta are Prithvi, Jal, Agni, Vayu, and Akash. So these elements are the building blocks of universe and the building block of the human body also. And these elements actually interpenetrate through the process which is called Parasparuna Pravesh, which where each successive elements inherited the quality from the previous ones, culminating, you can say, the Prithvi, uh, mm, uh, possessing the five sanitary qualities, which are Shabd, Sparsh, Roop, Ras, and Gandha. So these all, if we say about Shabd, Sparsh, Roop, Ras, and Gandha, these all are nothing but the Indriyas which we are having. And these Indris are something which actually when are actually the you can, the senses which makes us feel about the energy itself. So energy manifests as the dynamic balance among them, governing the physiological function, such as, you can say, the digestion. And now what digestion happens through bhutagni. That is something which is inside us, which is burning, and which actually helps in the digestive activity, and which is also responsible for the overall health and the harmony of the body itself. So in this way, these Panch Mahabhutas are, you can say, the combination with which our bodies are formed. One or the other way means, you might have observed that in in even in your this cold season, like my hands are always warm, but there are people, those who are having their hands are cold even in summers also. Their hands are cold even in summers. So why it is happening? Because this is something which is the combinations of these five tattvas, which has made our body is made of that, and these tattvas are not equal in all. So there is an elemental balance, you can say, amongst these Panch Mahabhutas, which are arising from the equilibrium, that is fueling the Tridosha. Or you can say what are these three dosha? You might have heard about Vata, Pitta, and this Kapha, which is there inside our body itself. So it's a combination which actually is told to us from the point of view of our Ayurveda. So this energy is having that impact also, you can say, and there has to be a balance in the elements. Then only the things are going to survive. Further, if we say sun is a primary source, you can say, or you can say Surya, or it is worshipped in Vedas like anything, and this is the source of life which is regulator of the time also, and sustainer of the ecosystem too. Now, the concept of yajna is also, you might have uh, heard about it. It is also a source of energy transformation. Actually, I will not go more in the mythology, because there are other slides also to be shown. So there are modern parallel also to this, or you can say the modern parallel to what we have just now discussed about the ancient, uh, you can say, the Indian knowledge regarding the energy is that the parallel energy concepts highlights how nearly our renewable sources trace back to the sun as a primary driver. So this unified view promotes the integrated clean energy systems for the sustainability. solar, wind, biomass, and hydrological cycles energizes the interconnect seamlessly, and they form a solar powered ecosystem, right? So it is more about you can say the if we talk about solar energy itself, it's you can say the direct sunlight actually if we capture via the photovoltaic panels, or you can say the thermal collectors, they convert the photons into electricity or heat. The sun bombards Earth with, you can say, 1,73,000 terawatts continuously, and this is 10,000 times more than the global demand. It means we are already getting 10,000 more than what is required by us. And if we see the technologies, like you can say the bifacial panels, they now exceed 22% of their efficiencies. So it powers daytime grids, but needs storage for the nights also. Let us talk about wind energy. So wind arises from the solar heating. It creates the atmospheric pressure differences, which actually drives the air currents. Offshore turbines in places like you can say North Sea, which actually generates 15 megawatt each, harassing kinetic energy via blades spinning the generators, right? So the global capacity hit 1000 gigawatts by 2025. So winds actually complement the solar energy by peaking at night, or you can say in the cloudy times. So these are replacement of each other, you can say. So when sun is not there, then winds can actually provide the supplement thing. Next is your biomass energy, or you can see this plant actually captures the solar energy through the photosynthesis we have discussed, and it stores a chemical bonds in woods, crops, and the waste. So anaerobic digestion actually yields the biogas, and when it combusts or gasify, it produces heat or power. So it offers the base load reliability unlike the intermediate solar or wind. You can say it is a second generation biofuels from algae or avoid food actually conflicts. So next is your hydrological, or you can say the generation through the hydropower. So hydrological cycles, there are energies being uh, generated through the solar evaporation, which lifts the water to the clouds, forming precipitation, and fills the river and the reservoir. So one or the other way, it's sun which is driving everything, and because of these things only, the rains happen, dams are there, they actually convert the gravitational potential into the electricity through turbines, and the hydropower supplies, you can say, about 16% of the global electricity, with pumped storage enabling the grid balancing. So, so everything whatsoever, if we see it from the point of view of energy, it is the sun which is the ultimate source, I would say. Now, the form of the renewable energy, which is the core of today's session, are these forms, because we have to take that also besides all these things. So, solar, wind, hydro, that is power, water, you can say, or the biodegradable wastes, or biological, you can say, things through which we generate the energy. These are the four forms which are there, right? So, first we will talk about solar energy. So, okay, any question up till now over here, if you have, or I hope I'm able to make you understand the connecting the things of energy with that of the ancient knowledge which we have, and the currently which are required. So any questions if you have up till now, you can even ask over here, or if you want to ask me at the end, you can ask at the end also. Any question, Lokesh ji? Any hand raised? Okay. So let us talk about the forms of energy, that is the solar energy, you can say. So solar energy harnesses the sun's abundant power as a clean renewable resource. Sun actually acts as an infinite energy sources. We just not talked about that sun is providing us energy which is uh, 10,000 times more than what is required by us. And actually it is doing it with the use of the solar radiation, which provides a mechanism for capturing it. If we talk about India, for India, when it's sunny climate we have, the solar power actually offers ideal energy security and the sustainability. So sun, which is you can say it is called as a infinite source of energy. It fuses 620 million metric tons of the hydrogen and helium every second, which releases massive energy in the form of heat and light. So this process will continue for another 5 billion years. Means this isn't just an estimate, making the sun an inexhaustible compared to the fossil fuels which we have. And as I have already told you, Earth is receiving 174,000 terawatts of the this solar energy, which is 10,000 times of what is being demanded at the global level. So just 1 hour of sunlight is equal to, you can say, annual human energy consumption. Annual. So unlike coal or oil, or you can say solar, oil, the solar energy will never deplete. And this is emitting no greenhouse gases, which is actually making our environment toxic. So this is about what actually is. So what is, you can say, solar radiation, or you can say the concept of the solar radiation itself. So solar radiation, or you can say isolation, measures the sunlight energy reaching the Earth's surface. So the sun emits the spectrum, that is the ultraviolet, or you can say the visible light, and the infrared. Three types of things are there. We can only see the visible light, ultraviolet, and you can say the infrared. These are beyond the scope of the human eye to see. At the same time, the photovoltaic panels, which actually converts the photons into energy via the photovoltaic effect, the electrons excited by the light generates the current, right? So concentrated solar power, or CSP, that uses mirror to focus the rays, heating fluids to drive the turbines, and there are certain factors which actually affects the generation of the solar power, which you can describe as the atmosphere, the latitude, and the cloud effect. Or you can say more clouds are there, less power will be generated. So there is something which actually is there in order to deliver a certain, you can say, quantity of the solar energy as such. So, why further the solar energy is ideal for India? As I've already told you that we are having more sunny weather. So, India receives actually 4 to 7 kilowatt hour per metric square daily solar isolation, among the world's highest across 300 sunny days yearly. So, this is something very, very good for us. Vast land, you can say, that is like in, you can say, arid Rajasthan, you can, it's Thar deserts. They suit the large scale farms, or you can say rooftop fit, which actually requires, which actually is there in the urban, which is needed. Okay, so these are the things through which the solar energy is being developed, and government actually targets 500 gigawatts of renewables by 2030, with 280 gigawatts of solar via uh, national solar mission, or you can say in our city Sagar also. I have just yesterday, day before yesterday, received a call, sir, solar panel lagwana hai kya? Because government is subsidizing that. So everyone whosoever wants to just put a solar panel, definitely it is, and the cost is as cheap as 2.5 rupees per kilowatt hour. And off-grid solar power actually, you can say the off-grid solar actually powers 300 million unelectrified citizens, enabling pumps, lights, cold chains, or for farmers, you can say, and it reduce import independence to 80% of the coal which we import. So it is reducing that, and it cuts pollution also, which is killing 1.6 billion yearly, and creates uh, about 1 million jobs at a time. And if we talk about the technical and the economic advantage, particularly from the point of view of this solar grids, so it is also very, very lucrative if we see it from that point of view. So if we talk about the crystalline silicon panels, which actually is having 95% of efficiency with a thin film emerging out of it. So or you can say bifacial tech captures, reflection lights are there, which actually increases the outputs to more than 20%. So there are many other things, like you can say battery storage, like lithium ion batteries are there. So these all are very much economic if we compare it with those of the non-renewable type of energies which are there. So economically, if we see 100 gigawatts installed uh, creates $150 billion market annually. And the states like Gujarat, Tamil Nadu, they lead with this 10 gigawatt plus capacity. So these are the opportunities which even Rajasthan is not able to tap that much what has Gujarat and Tamil Nadu has until now. And yes, there are certain challenges are also there. Like you can say, there is a lot of dust which actually reduces the efficiency to 20 to 30%. But at the same time, if we use the robotic cleaning and anti-soiling coatings, they help a lot. But the monsoon also limits the output because there are clouds for that, because it covers the sky with the cloud and doesn't allows the sunlight to reach the photovoltaic cells. And if we see the grid integration, it needs small meters and transmission lines, and 2.4 lakh crore investment is required and is planned particularly in this area in order to fund this the solar power. And further, the solar power, India's development, if we see from the point of view of rural women gain independence via solar lamps, you can say factory run can run 24/7. I just told you the example of Gujarat, where uh, uh, there is no light cut at all, and we have just now come up with some good this electronic vehicles also. They are charged and they also run. So as the cost fall further, the solar becomes the basehold power driving the net zero by 2070. So by 2070, or you can say 2070, if these things are developed in that way, so we will be able to get our net zero. That is our all requirement will be fulfilled using the solar itself. So this is why it is ideal for India also. So there are various type of you can say solar energy which are you can say solar photovoltaic are there, solar thermal, rooftop solar are there, and utility scale solar parks are there. Means at large scale these things are carried on, right? So, in the form of the renewable energy, or you can say, if you can see this table, there's a comparison and the future things are given. Comparing the PV's thermal rooftop and that utility, the output cost and which type of thing is best for what type of you can say uh, requirement, or you can say what will be the storage fit for it. So this chart is actually there to help you out. So this table is actually a comparison of the four energy types, which is based on the output cost. It's idle application, which is best for what, and the storage capacity, which guides the efficient deployment of the strategies. Right. So if we see PV actually generates the direct electricity at the lowest cost. Right. It is the cost is almost very low, lowest cost you can say, which is 0.03 to 0.05 dollars per kilowatt hour, which suits versatile use from the gadgets to the industries, paired with the batteries for you can say nighttime reliability. Okay. At the same time, if you see thermal, which this produces heat or power at a certain higher cost, it's 0.06 to 0.10 dollars per kilowatt hour, but excels for the base load, which needs like you can say constant factory supply is required, or leveraging the molten salt storage for extended dispatch, right? And at the same time, if we talk about the rooftop system, it delivers 1 to 10 kilowatt for homes at the moderate cost of 0.04 to 0.07 dollars per kilowatt hour, enabling the self-consumption and bill savings through small batteries, you can say. At the same time, the large-scale utility scale parks, the output is 50 megawatts. This is the cheapest. Why? Because of the you can say the economies to scale, which powers the grids with the large hybrid storage of for stability. So overall, if we see, the utility park offer the economies for mass supply, while PVs and rooftops they prioritize the flexibility if we see it from that point of view, and thermal actually fills the gap in continuous demand. So the cost reflect the scale. Okay, that is larger setup is are cheaper, like the utilities one, right? While storage matches the intermittency of the batteries or for the quick cycles, or you can say salt for the thermal endurance. So this framework actually supports the hybrid grids, blending the type of 24/7 type of renewable, 24 hours and 7 days type of renewable. So this is something which is there a comparison of the PV thermal rooftop and the utility. Okay. Next is your wind energy, or you can say what are the forms, or you can say the basics of the wind energy itself, if we see it from that point of view. So wind energy actually harnesses the natural movement of air to generate a clean electricity. So it relies on the wind's kinetic energy, because more with more speed, or you can say more vessel velocity the wind will be moving, the turbine will have more rounds, and it is created by uneven solar heating of the earth's surface, which drives the air from the high to the low pressure areas. So one or the other ways, I've told you before that sun is the source of all. So here the sun is also playing an important role, creating the difference in the air pressures, which actually makes the wind blow from one place to other. And when the things move, they carry energy along with them. So modern turbine efficiently converts this motion into power for homes and the grids, right? Because it moves the turbine and it is created into power. And wind as a kinetic energy, if we just see from that point of view, so wind actually carries the kinetic energy defined in the energy of the motions, right? Where you can say the air mass is multiplied by the speed. So faster wind actually packs more energy since the power scales with the cube of the velocity. Doubling the speed of the speed increases the power to the 8 volts. So air density also matters because how dense the air is. If the air is very light or it is very hot, it may not be able to move a turbine. So more dense the air is, or you can say the dense air are found when the how the air will be dense. Air are dense with the help of moisture. So when moisture is created in the air, it actually feels and then it moves the turbine in a better way. It is nothing just like you can say it's a you can say the law of motion. Okay, so air density also matters. So denser the air, which we found near the sea, they yield more extractable energy. So a turbine's swipe blade area captures this moving air mass with a larger rotors accessing the greater volume for a higher output. Okay, so the pressure differences and the air movement, how it actually affects. So when the pressure is created between the cooler and the warmer area because of the solar radiation, which actually heats the Earth's surface, the land warms faster than the ocean and it creates low pressure zones that draw in a cooler or you can say the light pressure air. So this flow generates winds from the gentle breezes to powerful gales. Another is rotation of earth or you can say it actually uh, because of the rotation of the earth also the wind actually blows or the rotation or you can say the surface features like you can say mountains and their shape patterns actually create the winds to blow. If we find globally the trade winds and the jet streams, they provide a reliable source, specifically offshore where the friction is low. So these dynamics actually ensure the wind predictability, and these are vital for the selection of the site where you have to put the windmill. And the conversion of wind to the electricity is done with the help of the turbines. And you might have seen each and every wings of these turbines are so huge that we cannot even imagine of. Means there are 3 trucks are required in order to carry these from one place to how the installation would have happened. Just see that how the installation of the windmill happens specifically in mountain areas. Okay, so there are some you can say the mechanics or you can say the mechanism which actually is a combination of you can say the round per minute or rpm of the gearbox or electromagnetic induction which actually happens which converts the energy wind energy into the wind into the energy or consumable energy itself. Now there are various forms of you can say wind energy. This comprise of onshore wind, offshore wind, and small turbine blades. So wind energy system harnesses the kinetic energy, as I've already told you, moving air to generate electricity, serving as a cornerstone of the renewable power. They primarily feature onshore wind, offshore wind, and small turbine, as is depicted in the slide. And each is suited to specific environment. Means everything cannot be placed at everywhere. So these systems convert the wind to the mechanical energy, to the rotating blades, and then to the electric energy through the generators. So what are onshore wind systems? So onshore wind turbines operate on land. That's what is called onshore, right? So typically in the rural areas or the hilly areas where there are steady winds. So horizontal axis turbines are there, which are called HAWTS. They dominate with three blades on tall tower. You might have seen wind the turbines, and you can see it in the picture also. And which are these towers are very high, means 80 to 120 meters high, and they face towards the prevailing wind side. So they range from 2.5 megawatt capacity, powering thousands of homes per unit. And the advantage of this includes the lower installation cost. That is, you can say 1 to 2 million dollars per megawatt, and it is easier to maintain through roads. You can say. Now, if we talk about our country, our country leads with over 40 gigawatts capacity, targeting 140 by 2030. So presently, we have 40 gigawatts of capacity, and by 2030, because we are also targeting the sustainable development goals, we have a goal of 140 gigawatts by 2030. And challenges, the challenges which are there in installation, it involves a lot of noise. You can say the bird impacts are there, and the land use conflicts in India, which actually makes our infrastructure very challenging sometimes. So this is about the onshore. Likewise, offshore wind systems are there. So there are offshore turbines also, which stands in the sea or the lakes, tapping stronger inconsistent winds up to 50% higher speeds. So the fluctuation of wind is very high in case of offshore winds itself. So they have the fixed bottom monopolies, or you can see the floating foundation support. Both type of things are there. So 12 to 18 megawatts units with the, you can say, longer blades, or you can say 100 plus meters blades are there. Now here the Europe is having dominance, which with the 30 gigawatts, while US projects are also there in competition. So these are producing the energy at 3 to 4 million pounds, million dollars per megawatt. And because of this marine logistics and corrosion resistance, it is these are the, you can say, factors which actually adversely affect the production of these things. In the same way, there are small wind turbines also, and these small wind turbines are under you can say 100 kilowatt, and these are often from 1 to 10 kilowatts. They are served at from the point of view of generating electricity, and they propel homes, farms, or you can say the remote sites. And these things are, you can say, the vertical axis, or you can say compact horizontal axis type of turbines, which actually are mounted on the poles, which are not more than 10 to 30 meters. They offset actually 50 to 100% of the household electricity with the, or you can say, it also generates sometimes payback in 6 to 10 years at 3,000 to 8,000 dollars per unit. And there are hybrid setups are also there. So hybrid setups pair with solar for reliability, because it is something which is a mix of both. Because here the wind and solar, if they work together, more reliability will be there, because one work in day and another work at night. So this is ideal for the off-grid Indian villages, and they face a variable output, and they zone limits, but they are unable uh, for energy independence. You cannot completely depend on them for your energy supplies. So if we see the comparison chart, particularly regarding the onshore, offshore, and the small, this table actually compares the three wind systems across the capacity, cost, advantage, drawbacks, and aiding investment in the side. So onshore wind actually offers a moderate capacity of 2.5 megawatts per turbine at the lowest cost of 1 to 2 million dollars per megawatt, making it accessible for the land-based farms in windy type of plains. So its affordability and the road access, which actually enables the quick scaling ideal, which is ideal for developing nations like our country. Though noise pollution and the farmland competition, they pose a lot of challenges which we have just now discussed about. Likewise, offshore systems, they deliver 12 to 18 megawatts with the steadier ocean winds, because offshores are on oceans, and they boost output by 40 to 50%, and justifying the premium cost of 3 to 4 million per megawatt. They actually minimize the onshore visual noise impacts, and serve coastal grids efficiently, but corrosive seas, or you can say, they demand the costly anti-rust maintenance, and the specialized vessels are required in order to carry these. So these are the challenges also it has along with the production. Small turbines, as we know that it is not more than 100 kilowatts, and it is they generate 3,000 to 8,000 dollars per unit, and prioritize the decentralization for homes, farms, and they offer placement flexibility without the vast lands. They promote energy independence in remote areas, but still they suffer a lot of things. Means they are also suffering with the low efficiency during the calm spells, or you can say there are when the winds are not there, and limiting the reliability without the backups. Overall, if we see, the onshore suits actually budget the bulk power. Offshore actually maximizes the yield in premium sites, and small, you can say, uh, small turbines, or you can say small uh, systems actually enables the microgrids. So cost scale is inversely with the size, while percent cost reflects the location trade-offs. So land ease versus marine durability versus portability. So these are the things which are actually contradictory. You can say they are trade-offs. So hybrid blending type optimize the global winds, because 1,000 plus gigawatts potential is there. So this the more important thing is that you cannot completely rely on the wind as such, until and unless it is supplemented with that of the solar. Okay, now the hydro. So what hydro energy is, and hydro, you can say something which is related to power, or you can say it is something which is known as hydropower, or it harnesses the power of flowing water to generate electricity. Dams are there, which are you can say the main reason of construction of dams are to harness the power of the flowing water for generating electricity. Now, it stands as the oldest form of renewable electricity, which roots tracing back thousands of years. So this clean energy source actually converts the water motion into the usable power through turbines and the generators. Right. So it is actually called energy from the flowing water. So flowing water contains the kinetic energy due to its motion, and it is derived from the rivers or the streams, or you can say the dam, where dam release reservoirs, where the dams actually are supposed to release the waters in order to move the turbines. So in hydroelectric system, this energy drives the turbine blades, spinning a generator to produce electricity, like it happens in the case of the wind, where wind actually blows off the turbine of a windmill, and the electricity is produced. So the process begins when the water actually passes through the intake gates, accelerated via penstocks to strike the turbines at the high velocity. Unlike fossil fuel, hydropower uses the natural downhill flow of the water, making it renewable as a water cycle, evaporation, precipitation, and the river replenishment actually sustains. So this is something which is, you can say, the reservoir actually never empties. Why? Because with the help of rains, it will always be filled. So globally, it supplies about 15 to 16% of the electricity, which large scale plants like, you can say, we have the Bakra Nangal Dam, which was also another dam we have in Odisha. So these are the big dams India is having, and there is a dam nearby our place Sagar also, uh, where the electricity is being generated with the flow of water. So here the main thing is the gravitational potential, which actually converts the kinetic energy into the this mechanical energy. So there is another, we can say, there is a historical significance as the oldest and the renewable oldest renewable electricity. So hydropower actually is, you can say, it is having its own legacy. Now you might be thinking that sun is the source which is the more ancient. I agree with you, but the thing is that the process of conversion of sun's energy into electricity came very late, or you can say it is just a recent development where the solar cells have come into picture. More the things are based on the hydropower itself, right from the beginning, if we talk about the renewable. So hydropower legacy actually spans millennia, predating modern electricity. Ancient Greek and Romans also used to use this water wheels for milling the grain over 2000 years ago. In India also it has been used since then, which was used to be called as the Jal Chakki and the Pavan Chakki. Both of the things were being used and from since then. Now, what are the key advantages and the modern relevance to this hydropower is that it offers very high efficiency. That is up to 90% and longevity of 50 plus years. And there is zero emission during the operation. So it supports sustainable development, which aligns with the SDGs by providing base load power in regions like India, where the projects like those on the Narmada River aid energy securities. Right. So challenges are there, which includes the ecosystem disruption and drought vulnerability, spurring runoff river, and small hydro innovations. Right. So as means as this is, you can say, one of the most important source of renewable energy, and there is abundance of water and rivers in India. This is one of the most important source, particularly in the country itself. Now there are various types of hydropowers. Large dams are there, run-off river projects, and small and micro hydel are there. So I'm not going in depth about all these things. Next is your bio. or you can say the basics of bioenergy. So bioenergy actually harnesses the energy from the organic matter, transforming the waste into the valuable sources while aligning the circular economic principles. So this renewable approach actually reduces the reliance on the fossil fuels and promotes the sustainability. At its core, if we see, the bioenergy exemplifies the waste to wealth. The concept by converting the discarded material into power, heat, or fuels. So if we talk more about this particular type of energy, bioenergy actually derives uh, the energy from the biomass, which includes the plant material, animal manure, crop residues, and municipal organic wastes. So these sources store solar energy captured via photosynthesis, making bioenergy renewable as a new biomass regrows quickly, unlike the finite fossil fuels which actually burns out. Okay, so conversion methods include direct combustion for heat and electricity, or anaerobic digestion producing biogas, or you can say methane rich, and thermochemical processes like gasification or pyrolysis, yielding syngas, or you can say bio oil and the biogas. So these are there. So there are energies which are generated from the organic matter, which serves as a foundational feedstock for the bioenergies itself, right? So another concept is regarding waste to wealth concept. So this is also looks very lucrative. Now we are having something which is waste for you, and you can create wealth out of it. So the waste to wealth paradigm actually turns the liabilities into the assets. You can say from the accounting point of view, because I'm a man of accounts. So from this point of view, if you see, so it actually converts the liabilities into assets. So organic waste, or you can say these are sometimes they become they are used in the biogas plants as an inputs. They produce energy while yielding the digestate as nutrient-rich fertilizer. So whatever is being wasted is again being utilized in order to generate more energy, or you can say more money, making more money. So biorefineries are also there, which actually maximize the value by co-producing the biofuels, biochemicals, and electricity from one feedstock, fostering the rural jobs and cutting import dependence. Now, if we see globally, the bioenergy supplies over 6% of the renewable energy, which is again a substantial one, with potential growth via algae or advanced residues. So this is something which is there. Now, how this circular economic model works? So bioenergy actually embodies the circular economy tenets. How? It eliminates waste, circulate materials, and regenerate the nature. Instead of being linear, or you can say take, make, dispose, the biomass loops back the waste fuel energy, byproducts, unrich soil, minimizing pollution and resource depletion. So integrated systems like waste to energy, uh, you can say they reduce the greenhouse gases, and they support the sustainable development goals on sustainable energy, and are responsible. Uh, they come under the responsible consumption, and they drive the economic resilience. So in this way, where we are not able to, where they, if we see it from this point of view, that's something which is actually it actually consumes a lot of money to eradicate the waste. At the same time, that waste is useful for us, which actually is giving us back some money also, or some energy in the way of input. So this is what you can say embodies the circular economy. Now there are certain challenges also there, which include the sustainable sourcing to avoid deforestation, but at the same time we can have the optimized chains that ensure the net environmental gains. So this framework actually positions the bioenergy as a pivotal for India's renewable goals also, which leverages the abundance of agriculture waste for decentralized power. Now, there are certain forms of bioenergy. We know it very well. Biogas, how the biogas is produced and how it is. Biomass power is also there, and ethanol and biodiesel. You can directly generate certain fuels, or you can say oils from Jatofra. You might have might be knowing about. So this is something which is produced in order to make the biodiesel, which can be consumed directly in the vehicles itself. So these are the things which are there. Further regarding, now this is very important, which actually makes a comparison of the solar, wind, hydro, and biomass uh, uh, sources of energy through availability, cost, environmental impact, reliability, and suitability for our country. So, if we see it from the point of view of from solar, so solar actually excels in the availability and cost because it is already there and dominating India's 203 gigawatts of renewable energy capacity with 92 gigawatts are installed means we have to go for installation of another more than 100 in order to cover our sustainable development goals by 2030. And this is also supported by the schemes like Prime Minister Surya Grah, where you can install the solar panel and you can get the subsidies from the government. Wind actually complements solar in the hybrids, leveraging 48 gigawatts capacity in you can say windy areas like Gujarat, Tamil Nadu. Hydro actually provides the reliability, but faces the environmental and the site constraints. While biomass suits India's agroeconomic or you can say waste to energy. So, if we see it from the point of view of interpretation, this comparison actually reveals solar and wind as optimal for India's scale up towards 5,000 gigawatts non-fossil target by 2030, given low cost, which is now as compared to the coal, as you can see, and high sustainability amid abundant resources. Now there are certain challenges also, and these challenges are like intermittency demand, intermittency demand storage, and hybrids. But environmental benefits actually far outweigh the hydro biomass trade-offs. If we talk about prioritizing the solar wind hybrids with the hydro based load assigns with India's tropical climate, rural areas actually need a net zero goal by 2070. That is what is required. So, this is actually is a brief comparison of all the things. Now, another thing that why we need renewable energy today is very simple. That there are biomasses which are converted into coal, oil, or gas, and now we are coming up to the renewables because these things will be traded off, or you can say it will go off after a certain period of time. If we talk about industrial revolution, the fossil fuel dominance will not be there to the much extent, and consequences we are already facing, that is pollution, climate change, and the resource depletion. These are continuously happening to us. And why it is prominent is very simple. Climate change and global warming is happening everywhere. There is a need of energy security now, and rising energy demand is also one of the things which actually fuels up the use of the renewable energy today. And there are international commitments, or you can say the SDGs we have to go for, and technological advancements are required in order to, you know, proceed further for towards the development. And reduced cost of renewables, or you can say cost reduction in the renewables, is also one of the most important way why we should go for the renewable energy today itself. Now, another important thing, why we are studying all this, why the most important thing is that why we all faculty members, or why we all teachers are being taught this particular energy. So, as a role, as a teacher and a faculty, we play a pivotal role in embedding the renewable energy into education, fostering the sustainability skills amid India's push for 500 gigawatt of non-fossil capacity by 2030. So they drive a curriculum. So curriculum integration is important thing. Research opportunities, awareness generation, and interdisciplinary teaching. So these are the things which are there with the help of which the teachers can actually play an important role. So they actually drive the curriculum updates. They spark the researches. They build the awareness. They guide the project and link the disciplines for the holistic learning. So curriculum integration is one of the things by which the faculty integrates the renewable energy by weaving the topics like solar PV systems, wind turbines, and energy storage into the core subjects such as physics, chemistry, environmental science. In CBSE schools and the universities, teachers are updated their syllabus with NEP 2020 guidelines, using a case study from India's 203 gigawatt renewable capacity to replace the outdated fossil fuel focus. So they design the modules with simulation and real data from MNRE schemes, ensuring the students grasp that LCOE trends where the solar now actually is costing 2.5 kilowatt hour. Only very few means this is something which is less than the rate of the electricity which we are paying. So training via workshop actually equips the educators to embed these, you can say, these things without any extra load. As we can see, Terry Hydro Development Corporation has also funded a project which is there for a green school project reaching 110 schools, particularly in India. So these actually builds the foundation knowledge, preparing the graduates for the green jobs. Right. So this is awareness is our duty to make the people aware, change the curriculum from our point of view. Even if we cannot do anything, we can at least embed certain case studies which are related to renewable energy in our own curriculum. Okay. So this is thing. You can say another things are research opportunities, or you can say the factory, this faculty mentor or the students in the renewable research. They can link the academia to the industry through MNRA internships, ICSSR grants. So they supervise these on the topics like you can say perovskite strike solar cells or offshore wind viability in Gujarat, or you can say this. There is a agency called DST SCRB. So they actually fund the projects with this, which are having this renewable energy or something related to it. So in universities, like you can say IITs, the professor they guide PhD scholars on the hybrid systems. They publish in the Scopus journals and they come up with the patents and the innovations. So teacher facilitates the collaboration with the with these bodies, turning the labs into the R&D hubs for biomass gasification, which actually suits the India's this agro-based wastes. So this exposes the students to the funded project, boosting the employability in these areas. The faculty also evaluate the impacts, or you can say disseminating models for the nationwide replication. So awareness generation is can be done through the teachers, through seminars, eco clubs, and guest lectures from the experts like SACI officials. They organize rallies and the quizzes on the sustainable development goal number 7 and 13, and they use Earth 5R toolkits for climate pedagogy, like in Maharashtra schools they are doing it. So faculty actually they leverage the social media and the other platforms to extend the reach, as there is a concept called Green School 2.0, which engages 35,000 students across the 6 states. So in classroom, they highlight the India's solar leadership, that we have just now achieved 92 gigawatts of the installed thing, and they help in countering the myths. Okay, so these are the things which faculty can do. Student projects can be done. The faculty can guide the hands-on projects, like you can say the building mini wind turbines or the solar cookers to the kids from certain agencies, MNRE or others. So students prototype or IoT monitored panels or biogas digesters. They can actually, they can come up with certain innovations, and they can face national hackathons like Smart India type of projects. And professors, they provide mentorship from the ideation to the prototyping, evaluating via rubrics on efficiency and scalability. So in rural colleges, the projects actually address the local needs like rooftops, solar, or off-grid villages. They foster the innovations, particularly in these areas, and then they try to get more employment and funding through this. So there are various things which can be done. In interdisciplinary teaching can also, you can say, enhance the knowledge of the student through workshops, or you can say the training programs targeting SDG goals. So in summary, you can say that the faculty can transform the education into the sustainability engine, and they can align the India's green transition to the proactive roles across these aspects. So that is why this FDP is there. Okay. So I've already discussed. So there are certain areas where in commerce and management, the green finances can be taught. ESGs are one of the things which are their environmental social governance, which we call it as such. In the arts and humanities, you can say educators can explore the ethics and the sustainability narratives in the renewable transition. They can analyze the literature on this energy humanities, like Diosophian tales of the fossil dependency versus the utopian solar futures. Means I have just taken a few from the literature itself. In social sciences, the policy development and the equity, these things can be emphasized, backing it up from the point of view of the renewable energy. In education sector, environmental pedagogy is one which is very recently coming up. That how can you teach the environmental, you can say, protection type of thing in various colleges and institutions. So there is a separate pedagogy developed for particularly which education sector, or you can say the Department of Education can go for. Science
Uh,
and engineering, yeah, I'm
Excuse
just,
me, sir.
yeah, I'm winding up. Don't worry.
Sir, our second resource person have been joined, sir. So
Okay, I'm just winding up.
yes,
Just five more minutes. So energy and science, they are having they already have their, you can say, forte, particularly on this energy and power part. So teachers can actually collaborate on interdisciplinary capstones, like you can say biomass from agro waste. So IITs or you can say IIMs, they mentor the startup, translating the research into the developments. Right. So overall, if we say the teachers as a knowledge brokers catalyze the holistic renewable adoption, blending the discipline and the blending the discipline specific insights for the societal development, that is more important. So there are certain things regarding the sustainable and Viksit Bharat renewable energy and the self-reliant India. So in conclusion, I would say that renewable energy is not merely an option; it is a necessity for survival, sustainability, and sovereignty. Right. So this is something which is okay. Thank you so much for listening to me, and I have taken a little bit more time than was given to me. Actually, I started also a little bit late, so I think this is acceptable. Thank you so very much. And at this outset, I would like to thank my friend Dr. Lokesh Uke for providing me this particular thing. And one more thing is there, one more lecture, particularly on uh, research part, is also there at the towards the end. I have already requested it. If it can be adjusted, that would be great. Anyways, thank you, and I'm heartily thankful to Professor Y.S. Thakur sir, our Honorable Vice Chancellor, for allowing me to be a part of this particular uh, colloquium of all the faculties and researchers all together over here for this particular time period. Thank you so very much, and looking forward to see you again. Thank you.
Thank you so much, sir, uh, for providing your valuable time and enlighten us for your precious knowledge, sir. And I hope all the participants will get a precious knowledge from your side, sir. Thank you so much, sir.
Thank you so much.